Good evening. This is Shachar Peled, and this is the 10th video in our series on evolution and faith. This is the second clip in which I will be speaking about the proportions of evolution. Last time we began looking at the proportions of man and came up to light, a light year. And the last thing we said was that 1 light year is a huge distance compared to the human ability to walk. If 1 light second is enough for light to encompass the Earth 7 times, then a light year is something almost inconceivable. As proportions, Mars is far away from us, only about 4 years. And to the edge of our solar system, it would take about 6 million years to get there with a jet plane at 1,000 kilometers an hour. And that's just within the limits of our system, of our solar system, our sun. However, what about other stars? Well, it turns out that the nearest star to us is 4.3 light years away. The next one, Sirius, is 8.6 years. And the center of the galaxy is 26,000 light years away, which is zillions and zillions of kilometers. It's huge, beyond conception. Andromeda, our closest neighbor, which is considered the furthest object that one can see with the naked eye, is 2.46 million light years away. Remember, 1 light second is 300,000 kilometers. 3 seconds is 1 million kilometers. So can you imagine 2.6 million light years? The distances are mind-boggling. And there's something about this that gives us an ability to look into the world, the physical world, and see the enormity of it, and have a conception of infinity. Some kind of inkling of what infinity will be about through the very mind-boggling distances that are physical, that we can measure. Indeed, since we measure distances by light, then the further away an object is, the longer its light comes to us, because light is the maximum speed in nature. So if a light leaves the sun at this moment, it takes it 8 minutes to get to the Earth. So if the sun should go out at this very moment, it will take 8 minutes until we know it. Now the nearest star is 4 years away. So it will take 4 years for the light from that star to come to us. So the light from the Andromeda, for example, galaxy, took 2.6 million years to get to us. And as we look deeper and deeper into space, we see further and further in time, in fact, because the light comes to us from the past. So indeed, 13 billion light years away, we look really almost at the beginning of time, beginning of the cosmos, which is time and space created together. And it slowly expands the cosmos from the original Big Bang. And if we look at the greatest distance, we see the origins. So Hubble recently managed to get a picture of a galaxy that was formed just 700 million years after the Big Bang, more than 14 billion years ago. So we are looking at the very source of time at enormous astronomical distances. Everything, all that there is, was formed in the Big Bang and is expanding since then. For one moment, there was nothing, absolute nothing. It wasn't a nothing in nothing. We say something is in space. It was complete absence of anything. And then there was a bang. What's called the Big Bang, an infinitesimal point of infinite density that is expanding since then, and this is our cosmos. It's inconceivable. So, what is the evolution of the cosmos? We talk about the Big Bang, but we are very far away from the Big Bang. We spoke about 15 billion years ago. We know that life on Earth originated about 3 billion years ago. So that's a lot of history before life on Earth, before we begin to speak of Darwinian evolution. So what happened after the Big Bang? If we look forward, or backwards, after the Big Bang, we will see that from this moment, this infinitesimal moment of nothingness, suddenly there was a thing. Not a being, but an existence. Something came. There was it was no longer nothingness. Yeah, you can say it was being, not being in the sense of a being, a live creature, but being in a sense of it was. There was something there where there wasn't before. And that was the beginning of the cosmos. Before there was nothing. So it's creation ex nihilo. It was nothing before and suddenly there is. And since then, we have been evolving. So there's a lot of evolution in the very first second of the cosmos. Scientists talk about the weak strength, electromagnetism, strong interaction, weak interaction. I won't go into all this, but basically what they're saying is that there was evolution during the first second after the Big Bang, and it's measured in Planck times. Planck time is 10 to the power of minus 42. It's like 42 zeros after the decimal point. It's very, very, very small. It's infinitesimally small, but this is the shortest period of time that we can address, that we can speak of. And this infinitesimal period of time is used to measure eons, by comparison eons that happened in the first second of creation. Like everything is so speedy, but in proportion, it's like a long time passed before each event. And about 1 second after the first, after the Big Bang, there are hadrons, protons, such as protons and neutrons. And then up to 3 minutes after the Big Bang, most hadrons and antihadrons destroy each other, and there are mainly leptons left. Then about up to 20 minutes after the Big Bang, the temperature of the cosmos goes down to such an extent that atoms can form. So you see all these things that we take for granted, atoms, leptons. I don't take leptons for granted, but the scientists take them for granted. And all these were part of a kind of evolution. When the cosmos began, they weren't there. They formed over time, even though it was very short periods of time. Then there's a very long cosmic period called the photon period, which takes up to about 380,000 years after the Big Bang. And then the cosmos is full of photons that interact and eventually lead to the formation of atoms. It took almost 400,000 years to create the first atoms, so what's wrong? Why not? Then, after about 300,000 years, there begin to be formed atoms of hydrogen and helium, and the density of the cosmos decreases. At first, they don't have electrons, but then the cosmos grows colder, and electrons are captured by ions, and they become neutral in their charge. This is called recombination. This is a very long process. The point here is, anyone who wants to look it up can look it up in Wikipedia, but the point is, it's evolutionary. There's a process here. Then the first stars appear when the cosmos is about 400 million years old. That's a long time. There were no stars. Just Big Bang, a lot of mass, a lot of gas, a lot of electrons and atoms and whatever going around, swirling around. And then let there be light. Then the stars began to shine. And these stars were the places where all the atoms were formed, all the elements. So the first elements were formed in stars, but it takes a long time, and now scientists are talking about generations of stars, and each generation created heavier and heavier elements. The first generation stars created the lighter elements, and only later, when stars began to blow up and become supernova, then in the heat of the explosion, heavier elements were formed. So the later stars, the younger stars, are already an evolution of the previous ones. And all the elements also evolve. They are growing, they are becoming with the evolution of the cosmos. So in our galaxy alone, there are 100 million suns similar to ours. And they have materials inside the suns. The elements are identical to those on Earth and to the same elements from which life has formed. It seems that Earth itself, like other planets in the solar system, was a huge ball of fire that was accompanying the sun. And while the sun continued to burn, Earth was too small to maintain its burn, and it slowly cooled down. And metals, iron and other metal elements sank inside the Earth, and inside they are continuing to burn. The core of the Earth is magma, is lava. Lava is when it goes out, magma. It's boiling. It's like a star, a mini star inside the Earth. And the metals within the Earth's core, they create the magnetism of Earth. And this magnetism protects us from the radiation that comes from the sun. It's all a very complex but very incredibly balanced system. So the ancient Earth was descended from ancient suns. And all the great elements inside the Earth were once within suns. And let us get ahead of ourselves. All the elements in our bodies and in all life were once within suns. So we are the children of suns, even before we are the children of monkeys.